Should be live on YouTube now.
Excellent. Well, welcome everyone to the March 2021 Alaska Developers Alliance online meetup. Before we get started, I first want to recognize that the Developers Alliance works within the traditional lands of the indigenous peoples of Alaska. And here in Alaska, we're located on the traditional territories of the Dena'ina peoples, those of us in Anchorage. So I want to acknowledge the place-based knowledge of these peoples, and I'm grateful for their ancestral and current stewardship of the lands. I'm very excited tonight to have Mutable, and specifically Antonio Pellegrino, who goes by Pelle. Am I getting that right? Am I saying it right, Pelle?
It's simply Pelle, but
Pelle, okay.
Basically
very sorry. All right, so Pelle, thank you, is the co-founder and CEO of Mutable, creating the public edge cloud that delivers faster internet and better quality of service for customers by essentially acting as an Airbnb of servers. Mutable empowers developers to deploy next generation applications on its infrastructure by reducing latency and boosting security and increasing bandwidth. I know these are very important issues for Alaska. We're 45 or 50 milliseconds from Seattle, depending on where you measure from. So it's exciting to hear about what you're building and how it pertains to all of us up here. Please take it away, Pelle.
Yeah, no, it's fantastic. I have never been to Alaska and I need to make that trip. And I'm pretty sure Scott actually told me that no one truly, works with GCI properly unless they go out to Alaska in February. I heard that's the pilgrimage that needs to happen. So
it is the litmus test for any vendor that comes up.
There you go. So with that in mind, I have heard what's going on and what's different from what's going on in Alaska versus everywhere else. You are a kind of secluded island, right? To some degree, a very big island by that measure, but sorry about that. A very big island, but a secluded one in that measure, where everything goes down to what you guys call the lower 48, right? And that essentially has driven internet prices to be quite high, the speeds to not be as fantastic as they could be. Bandwidth to be, I guess, scarce to some degree. And that doesn't need to be the case, right? The internet is kind of broken. I'm not going to lie. It wasn't built for how we use it. It was basically built with the idea of, hey, look, there's research universities that has, some data on the other side. I should really look at what that data is or what that website is, right? Not, I'm going to run my computer, let alone everything that happens in my life on top of it. And that's what it became, right? It has become this like extension of yourself. And it's going even more and more that direction. I heard someone here talking about, drones and where we're seeing that going, and autonomous vehicles and all these things that are happening, or should be happening in these remote areas to try and, do autonomous things or get some life checks. I heard from the GCI guys, whenever there's something going on, like a generator breaking, that's huge, right? Like getting a generator out there is taking a helicopter out to put this new generator in. That's time, that's resources, that's not just, someone driving a truck going to Home Depot and replacing it, right? That's a totally different game. Everything's not right next to each other. Yes, you have a strong population from what I see in Anchorage, but everywhere else is, you have a lot of beautiful land and a lot of people like to, go in a bunch of that area, but not the internet. So we view the world a little differently. We try and view the world from a perspective of, what if you took all of the servers that are laying nascent, or servers that are laying nascent that are already in Alaska, let alone the rest of the US, right? Or the rest of the world. But think of all those servers that are in enterprises, that are in cable and telco companies that they use for themselves, right? Don't get me wrong. But the utilization is closer to like 5 to 10%, because they do it for the worst case scenario, redundancy, peak capacity, right? When everything breaks, you need to make sure that everything's good, especially more remote you are, the more cautious you are, right? Because how long it takes to get there. But no one has access to it. So it's technically there. It's technically could be used for people to run applications against it. But the reality is, it's in its own walled garden. No one can touch. What if we could open that up? Right? What if we took those existing assets that have already been paid for, or new assets that can come in that can be opened up to unlock all these experiences, to bring a Spotify closer, or not just a Spotify and Netflix, but the smaller guys, right? The ones that, you guys, find new technology and you want to use it, but feel that it's completely garbage because they aren't servicing your area. Because in their mind, they're like, well, who deploys things in Alaska? Right? But if we can make it as easy to deploy and run things in Alaska as it is everywhere else, let alone do it in a way where they don't even have to do it themselves, right? Many of you are developers, and that's why you're here. When you develop things, right, and you deploy things, a lot of us just do best effort, right? It's like, I run something AWS East, I run something AWS West, and good enough, right? I'll have to deploy 2 locations and cover the majority. But that's the problem with the internet. That's how everyone thinks. So if we instead made the model where when a user or device, asks to run something, because essentially it's an extension of that device or that person, that we spin something up on demand right then and there, next to that item, then that's how the internet should be, right? And don't think of the internet as wires anymore, right? We have to think of it as the internet is actually the actions that you take and the actions that need to happen in order to make whatever service that you're trying to run work. And so that's what we're trying to do, is democratize that a little bit, not running it on your home computer, right? I'm not trying to go that far, but there are a lot of spots that are on, traditional networks, especially. I think you guys have like Fairbanks is a big data center spot, in Anchorage, there's some. And then the idea is to get it by the harbors, get it by, all of these other remote sites. I think Scott has a good idea of where, potential spots where this can go, but we can definitely do a lot better. And then in addition to that, make internet cheaper because you don't got to ship the data anymore, right? You have control over your locations. You guys can put, towers and wires on your own location. The expensive part is whenever you give it to Telus, or if you give it to Rogers or whatever and run it down, that's the expensive part. So if we keep it inside of Alaska and keep a lot of this data there, then yeah, we can do all this fancy things that we've been promised for the past 20 years. Cloud gaming, cloud VR, right? A lot of this IoT things with drones and autonomy. That's totally possible. And that's where we're trying to work with operators like GCI and many others to try and basically bridge that gap by getting compute accessible right then and there for all of you.
Sounds fantastic. Do you have any, not to put you on the spot, but do you have any slides? Would you like to kind of dive into and unpack some of that more for us in terms of how you guys are solving that?
Yeah. Go ahead.
Pelle, sorry, I came in a little late. What's like so there's all this stuff. How do those assets get collated? Like, great, so AT&T's got some towers. Great, XYZ hardware's in the field. What's the strategy to like mesh it all together? Like, you're just building the thing that glues it, or how are you getting permission to use the stuff? Like,
yeah. So don't get Mutable confused with the idea of communications. We're not in the communications game. We aren't trying to put in 5G towers, nor are we trying to put in hardware ourselves. And that's the unique aspect of this, is because we're using other people's CapEx, because of servers already exist or are willing to put servers out there to improve customer experience. We're basically hijacking the bare metal. Actually, I can share something like that.
No, like, so right. So, I mean, like the way that like Netflix would like come to GCI and say, hey, do you want to have a caching server? So like everybody can share the same like Netflix. And so Netflix has boxes at all the little hubs. And I get that. So you're talking about bare metal. Are you sticking something like, I mean, you're taking over the hypervisor, or like what, how are you getting to the bare metal without somebody's permission?
Well, that's the thing. We are getting their permission. Right?
Okay.
So what we're doing is literally conversation happening right now, right? We're like, GCI, you guys want to improve your customer experience, especially gamers. They're like, hell yeah, we are, right? And so they're like, okay, let's start out. They're buying us servers out there in Anchorage, right? And they're putting it in. They're giving us access to those servers direct. We are then taking it and opening it up for everyone else. How we're doing that is we take over the bare metal, right? And then from taking over the bare metal, we essentially install our OS. It becomes part of our federated cloud at that point, right? And a developer would come to us. They'd use the Kubernetes API, right? Or KubeVirt for the, running VMs. So it's a standardized, traditional, regular, API that everyone's familiar with for the most part. They describe their pod and how they want to deploy it, saying how much CPU, this much memory, this much GPU, whatever it may be. But we also can add in things like latency, right? And so that's where we can have the serverless approach of saying, hey, look, when a request comes into the load balancer, we can automatically decide, hey, is this application based on that latency nearby? If it is, let's directly run to it. If it doesn't, let's spin it up, right? And then that's essentially how we're getting this ubiquitous of compute that's right next to everyone on demand, that's efficient, right? Like, don't get me wrong. We can go ahead and put pre-cache things. And, the whole point is that everyone can be like a Netflix without spending the CapEx like one, right? And that's the big aspect here, because we all know that, every application provider, everyone who's building things wants to make everyone's, have a best experience. Like, no one's purposely saying I'm not going to do something. It's just the convenience factor, how to do it and how to get access to it has always been a challenge. So that's where we're fitting in that regard. I don't have sharing capability, by the way. So.
Let us work on that here. And just to be clear, I definitely am setting aside time for Q&A. I want to make sure that I give you plenty of space, though, to kind of go over the platform, what you built, kind of maybe fill in a lot of the details. And then I'm sure we're going to have some very pointed questions here for you. And also, too, if you would rather just entertain questions, we can transition and move into that.
Yeah, I love... actually, for the most part, getting to know all of you and what your problems that you guys are facing and how this relates. So that's for sure. And we can totally do that while we figure out the share thing. But I'm also happy to share a few things if that makes it easier for all of you to picture what we're talking about here.
Sharing should be up. Give it another try here. You should be good.
Cool. I'm curious, who here is, a gamer that obviously would love for something like Cloud VR or cloud gaming to be here, but it obviously does not service your area. Anyone?
I mean, speaking for the VR community, I'd say, yeah, probably for immersive experiences, definitely not having to go round trip for a lot of that.
Well, even with that, right? You also have the new stuff with Cloud VR, where literally you can get the Quest 2, right? Oculus glasses, and then essentially not have the stick figure style, animation that you'd have on these devices. They're quite low power, but actually have full-fledged high graphics you typically would get with the $3,000 setup that you now can get, on this, just because you're actually remotely running this nearby, right? So those are the type of things that if you partner from taking the compute and moving it closer, you can achieve, right? So let me go through this in a sec.
Are you able to share? Are you good on that?
It seems so. Yeah,
okay.
It definitely seems so. This is window based, right? So if I share this, then I think I can just navigate around. All right. So we kind of went through this already, so I'm not going to go too crazy with it and can jump around, but let's see here. You guys are seeing this whole, graphic right now, right?
We're seeing your whole browser.
Cool. That's fun. I don't care. So essentially, right, you're seeing where we're coming from, right? The internet is broken, especially for all of you, more so than most. And that's really where we're coming in, right? And what we're talking about here is, instead of this whole idea of, this far cloud where, for most people, that far cloud means, 1,000 miles away, or a little bit less. I think in your case, it might be a bit more. And essentially moving that to literally down the street. And in your case, Anchorage, Fairbanks, and many other of these communities, right? And then federating that all together to create this ubiquitous cloud. What that means, if we were to picture this, right? Don't get me wrong, autonomous cars are not going to just go into walls. They're not going to be totally dependent on network, but the idea here is the response time and how long it takes to respond. If we can move that, the needle quite a bit, it actually can make a really big impact on the usefulness of being able to run applications nearby on the edge to take advantage and, take advantage of what's happening with the improved network speed and stuff like that. So when I was describing before what we're talking about, taking over bare metal, essentially adding our OS on top, federating all these clouds together. And I know you guys aren't just trying to make applications that just work in Alaska, right? So don't get me wrong. That we're federating all of the compute from every provider, working with T-Mobile. We're going to be working with Comcast, all these guys, and we're going to do it all together. So a developer, when they deploy once, they're deploying everywhere by effect. And then the key here is, and why operators would give us this compute, especially if they need it for themselves, is because we're prioritizing their compute. So that way, we'd have our stuff run, and then if they need it, they can always, we always can prioritize their use cases. But to go into more of the architecture, which I think is more interesting to some of you, actually, let's go into a diagram real quick. All right, so the internet is also broken in another way. Things aren't straight lines, right? When you try and make a request to even Seattle, right, or to Chicago, it is not, I'm going to go from your place to Chicago instantly. It is going to go through the most craziest BGP path that you can think of. And that also creates more jitter, more latency, more problems. And so by having things, on a network that's controlled, we actually can route things crazy efficiently, because instead of doing it by how the internet works, we can do it by how we think latency and throughput and all these congestion points basically can tie together, right? So, and if we're talking about cloud gaming, it's the difference of, I'm going to take all of your, your headset, right, or the game that you're playing remotely and bring it all the way to, Seattle or Oregon. Instead, you're literally running it in Anchorage. Same thing with game servers. Why? Like, many of you play with each other. You're in the same time zone, right? Not everyone's in that time zone, and you want to play with each other, especially your friends. So if we have these game servers literally there, instead of having, actually, I'm curious, what is the traditional ping for you guys playing games like a Call of Duty or a Fortnite or a Valorant?
We have from Demetrios 80 to 100 milliseconds. I guess those are ping times.
Got it. Yeah, that's a bit much. So imagine if you can be like most other people playing games and have it closer to 20 milliseconds. That would be definitely a game changer. Comment mode. All right, so these are these type of scenarios. These are things that we're deploying right now at Midco in North Dakota, South Dakota. As much as they're not Alaska, they actually have a lot of similar properties. All of those two states are very underserved. They're mainly one provider. That one provider takes all of the, the internet from, Bismarck all the way down to Rapid City and Sioux Falls, and everything comes down to Sioux Falls, then goes to Minnesota, then goes to Chicago. It's a very, obfuscated path that, everything has to come like a tree, right? Goes through all the branches to a trunk and then goes to the rest of the internet. And so by not having compute in there, you're getting a lot of these large latencies, because as much as it seems like it's closer, it's still the wires and how it's routed isn't. So now if we want to look at architecture a little bit, right? This is kind of, right now everyone has the far cloud and whatever else, but where's the ones nearby when all these data centers more or less exist, right? So if you want to geek out about more or less what we do and how that, kind of plays together, is we're taking over the bare metal. We have all these components from containers to, the OS level. We're taking that over with our specialized Nix OS for deterministic compute. That is our equalizer. So all of the compute that we get on our network is pretty much the same. And then essentially we wrap every container in these lightweight VMs for the isolation. So that way, if you have these telco workloads or your workloads, they're still completely isolated and have the multi-tenancy factor without the crazy overhead of a traditional VM. So this is exactly what Amazon and Google does. They use gvisor and Firecracker, and we're using the same.
So I see you breezing by a lot of COs there. Can you kind of explain that relationship a little bit, or are you going to get to that?
Sure. We're talking about this, or are we talking about?
Just I saw data co-location central office, and I'm very curious about these diagrams in terms of how how these relate.
Yeah. So what's also different about what we're doing here is that most of compute today is quite flat, right? Kubernetes, when you think about Kubernetes or Amazon, you're deploying based on a region, right? You're like, I'm going to take this piece of code and deploy it in this one spot. Well, when you have all these new layers, right? You have users are going to hit a central office. If you don't know what that is, in the telco land, it is where the wire goes to a building that goes to the rest of their network. Same thing happens in the wireless space. There's something called an MSO, or a mobile switching office. Same concept. Those towers with the radios have fiber wires that go to this location. For the cable side, they have things called head ends or hub sites. Same concept. Wires come in from your home. Maybe it's coax, goes to these fiber hubs, and then go to these locations. So these are physical micro data centers technically that are right near everyone, that most of them, it's under a millisecond in order to reach you, right? And those places are opening up for us to put compute in. Don't get me wrong. We're not talking about huge facilities. We're talking about shacks. We're talking about, less than an office building or a McDonald's size place, a Starbucks. And essentially those kind of places, we can start either putting compute on or opening up for others to use of existing compute. Then there's more regional data centers. That would be your Fairbanks or your Anchorage, right? And then they would have, POPs that are open to the public, right? So typically you might have one in Anchorage, or you might have one in Seattle, and that would be their connection to you, right? That's where like the Akamai's and whatnot are placed, the CDNs. And then you have the cloud. So our job is to go across all of this, right? And deploy your application anywhere that makes sense based on the profile of what your application is, right? And that's a new definition of how compute is. So it's another dimension to think about or care about, or multiple dimensions, more or less. And that's where we add a lot of value. And in these locations with all these cable and telco companies, what if we took all of the compute they have, we cloudified it, and we can shrink it all because they're not really using much of it. And then we can open it up for everyone else to use, right? And the idea, as we're saying here, right, is we're literally in all these places. We're in the central office. We're in the aggregation network. We're in the regional data center. We're in the national data center. We're in all these, other operators or cloud providers, and we're tying it all together to have one ubiquitous cloud where you as a developer isn't going to Amazon and saying, I need it in this region or this city. We're just knowing what to do based off of the things that you give us in terms of the profile. Think of like a Facebook ad, right? Where you put in demographics, you just put in demographics of how you want your application to be deployed. Then we'll spit out, UI and reports to try and showcase and figure that out with you, right? And where the best placement is. And because of all this different style of compute, you don't need to have the same buildings or redundancy factors in the big traditional cloud. Big traditional clouds, you have multiple generators, you have multiple everything, right? Basically expensive as hell because you have a large amount of data in one spot. Well, if we splice it up into all these, smaller spots and they're all in the same fiber rings, then technically if it's running in one building or the other building, who cares, right? And Amazon has the idea of like availability zones, and it's kind of similar. But what if you did that on a huge scale, right? Instead of it being like one city that you're doing this availability zone, you just did this for the entire network. You can have redundancy in the network itself, and that will lower costs and lower the barrier for other people to deploy things in a way that they're not really worried about everything going down all the time. And you won't have to retrofit all these small buildings to be like cloud compliant because you're relying on the network to do some of the redundancies and the software to do it for you.
So looking at like the different types of workloads that you have, I could see this working really well for something like Call of Duty gaming, right? Where in a sense you've got a centralized server that's central to all of the participants in the game, but how do you deal with something like web requests where you're still backed by a database that needs reliable like atomic storage? How would you distribute that?
Yeah. So it's funny because in our world, we see that as easier to some degree because the game servers, as much as they're local and for you, it's also persistent, right? The websites and the data of the databases are less persistent because they're cacheable. So what that means in a traditional website, what we would do is there's companies like Micrometa, right? And what they do is they basically do distributed database management and stuff like that. But the main thing is basically caching for databases. And we're seeing this all the time. Like if you look at what Netflix is, it is a cache of a database, just what's in the database is a video, right? So essentially you're caching all these things in all these locations. And essentially that's what gives you some of the speed. And the other factor is, web individually itself isn't a session that's really long lived. So those things can be moved around with load balancers at the edge of the network and then push this all the way up, right? We can have a secure connection from the edge of the network all the way to a cloud provider if need be, and also have the benefit of what, as you go from here all the way to far away, you actually can route the request in a way that's, faster and whatnot. So there's many different ways to make that experience actually take advantage of this. But a lot of it is going to be distributed databases, things like CockroachDB, things like etcd and all this type of consensus-based, Paxos-based, databases, as well as caching. People will use like RocksDB or Redis and be able to cache some of this content nearby and do those transactions and push those transactions up. And then lastly, you're just the content itself, you're using a load balancer to make sure that, can be served from any location for sure.
So in other words, it's great for things that are eventually consistent, but not real-time consistency.
Yeah. So the real-time consistency works with those distributed style databases that kind of have that kind of protocol built in. And then if you're doing things that are transaction-based that need to be globally synced, right? Typically those things are not as need to be real time. Now, if you're playing a game and you have game state, if you're doing AR, VR, where you have that game state local, if you're doing things like, let's just say autonomous, like drones, for example, autonomous drones that are going out and they're bringing back video and images and stuff like that and having that processed locally, that's totally fine to have something more, I guess, localized real time that we spin up DBs and everything else in order to compensate for that. But that doesn't necessarily need to have all that data be shipped to the cloud, right? Especially right off the bat. So there definitely is multiple streams, and I'm happy to, if anyone has any particular use case that they want to, talk about and see how that fits in, happy to do so.
I mean, I guess since we're doing this popcorn style tonight, I would kind of pivot off of just that remark you made about autonomous drones and kind of some interesting IoT applications. One of the things that I'm struggling with in my company as a hardware company is leveraging ways of storing information that I'm getting back from my vehicles, which includes video, as you say.
Mm-hmm.
And essentially knowing, as I move into autonomous systems, I'm going to have to, be processing that with the GPU. And I certainly don't want to be flying GPUs around. So I want to get those as close as possible
Sure.
To the aircraft, but not have that be in Seattle. So I think my question is, when you say giving access to the iron, is this something where, I can abstract away everything that I'm doing in terms of spinning up and down instances and interact in the same way I would with AWS? Or do I have to learn, a whole new system?
This is the reason why that we decided to use the APIs like Kubernetes and KubeVirt and stuff like that. So it's more traditional of how people are deploying things in AWS today. But yeah, so essentially what we're doing is you're not touching bare metal, but we are spinning up, just like AWS, all these virtual resources that you can get access to. And actually in Anchorage, hopefully in a couple of months, we will have a GPU over there, and maybe we can test that out.
Excellent. Also, keep your questions coming into the chat. Feel free to speak up. We're a fairly small group, but feel free to toss them into the chat and I'm happy to read them out.
Yeah, and let me know if you have any other questions about what the hell, like, I know too much, so I can go down a lot of rabbit holes, and I don't want to waste all of everyone's time with rabbit holes. So if you have anything targeted that you have questions about, happy to answer them. I know we're all engineers.
Can you tell us a little bit more? I guess I would toss one out there in a
Sure.
different way about business relationships, since
Yes.
the Netflix one has come up a couple of times. If I'm Alyeska Resort and I find that 60% of my inbound and outbound network traffic with GCI, let's say, is Netflix, let's say that it happens to be, do I want to approach you to essentially be doing Netflix caching locally so I can save all that bandwidth? Or am I hoping that you're going to partner with GCI to do that for us?
So to answer your question, we are a marketplace, meaning that we are bringing a lot of the demand into the market and then partnering that with supply. And the supply can be GCI, it could be others, right? We see that, as a global footprint and how people want to interact with it, a lot of it will be us basically pushing this onto operators and bringing in a lot of this demand related to that. But there are going to be cases where it does make sense to go a little bit more local to help solve a problem and then be able to leverage that same marketplace in order to, attack those problems. So the way that we're seeing this, right, just to give some context, is that we want to make this a traditional public edge cloud, right? Where developers can sign on, set up, deploy wherever they want. The reality is that we need to get enough supply, meaning enough locations from different sources to make that a global footprint or to make that compelling enough for you. So to help seed it, what we're doing is we're working with cable and telco companies, and they have their own demands, right? GCI, as we expressed, their biggest thing up front is gaming, right? They know that you guys suffer from it and they want to improve that experience. And so we went out and found, 8 companies that are doing everything from CDN from gaming to cloud gaming to cloud VR to network acceleration to game servers. And we're going to bring them on there, right? And that kind of seeds the market and gives a reason for GCI to open their doors to give us servers to put it there. And then we're also, for the telco space, the big thing for them, and also applies to GCI, is actually a lot of the 5G enterprise use cases. How do we take 5G and its benefits that it has of, more devices connected to these towers, higher throughput latency on the access network. And if we put compute at the, right next to it, we actually can make those things come alive. And we're shoveling a whole bunch of companies into that arena as well. Everything from AR glass companies that are doing it for factories or for, field techs to, enterprise networking stuff. And that's where we also are looking to this community, right? Not just to be, servicing Alaska for just that one need, but some of the things that you guys are coming up with is typically can be applied everywhere else, right? And so the benefit is if we're unifying or creating one way of deploying an application, we can put you out into the world and essentially say, hey, look, other suppliers can utilize you and take advantage of it, or customers in that area can, and therefore we'll help broker on getting that compute available. And then when it's probably in 2 years from now, will be more generally available as an overall, then, we'll get to that point where anyone's signing up to run anything anywhere, right? But it's not going to be a day one thing. Hopefully that answered some of your question. I know I kind of went on a tangent and brought it in a little bit, but.
No, that's fantastic. Any other questions out there?
Curious on one thing, Pelle, which is that, if you're thinking a bit about doing this work and the world of network infrastructure sort of changing behind the scenes, and I guess I'm sort of thinking primarily, let's say, like some of the oncoming, work with like low Earth orbit satellites, that kind of stuff. Where do you see edge computing going in relation to how networks are actually adapting, changing, and being built now? Because, you talked about sort of the older paradigm of how things are interlinked, but knowing what I know a bit about networks is like, that's not how they're being built going forward. So,
how does this work in the world of Starlink?
Yeah, Starlink's a good example, right?
Well, interestingly enough, it is still working that way. It's just hard to contextualize it the same. So Starlink and all the other satellite providers, they still need ground stations, right? So your data is going up, but then it's coming straight back down. And the question is, where are those locations that it's going straight back down to? And then it's on a traditional network, unless you put compute there, right? So to be fair, actually, all of this is the very hyper-convergence in that area where there's a lot of technology being done on the access network, right? Meaning, we had fiber for a while, but that's becoming more prevalent. We have 5G that's basically considered like air fiber to some degree. You have 10G, which is created by the cable companies, which is trying to have 10 gigabits pumped down a cable line. And then you have, the Starlink stuff, the satellites, the low orbit satellites, but all of them have the same problem. They're opening up the access network and making so that your device to these locations that we talked about, the COs, the central offices, the hub sites, all these things. And then there's the bottleneck from there, right? There's basically in the rest of the US and mainly more so, I'm sure, than over there, there's this gym membership model, right? Where essentially these locations, they're servicing maybe 10 to 50,000 people, and they're all promising them a gigabit, but the backhaul for that location is like 40 gigs, right? And so that's a 1,000% difference, right? Between 1,000x difference between those two numbers. But in their mind, they're like, well, no one's going to use this whole thing unless everyone's doing speed tests. But as you know, Bradley is saying what he's trying to do with it, with shoving video down there on the upstream, and how everyone's trying to do it with drones, and how we're talking about cloud gaming and cloud VR, that changes drastically. So I think the access networks are improving, and that's forcing more compute to be local in order to solve this problem, because otherwise people are, you're not really digging the ground over there. It's too cold or like too hard or whatever it is. So that distribution of the back end of the internet is still broken.
Yeah, thanks, Pelle. I mean, I think it's a fun conversation, sort of seeing the challenge of the whole world needs more, and it's one of these things that infrastructure is a really fascinating thing, that the pipes are never quite big enough if everybody flushes their toilet at the same time, right? And it's that fun issue that you have, same with the internet, is that you kind of need to continuously build for a certain scale of a use case that you hope never comes about. So
yeah.
But at the same time, you've got developers out there and people on this call that are developing solutions that may require to eat up all of that bandwidth instantly, and could affect whole communities. So I think it's great to see the edge conversation really sort of growing in Alaska.
Yeah, and I think it's also because how we're using the internet, instead of just downloading things, right, or utilizing it in a buffer or whatever it is, to now using it as a extension, like Bradley said. Why I would not put a GPU on a drone, right? Like, not because
people are trying.
I'm not saying it like it's because of expense, because it is. Not saying it's going to eat up energy like it will, but the other thing is it's freaking expensive. If that thing breaks, you're wasting money, right? On the device itself. So essentially, or it's a target for people to steal at that point, right? Free floating in the air. So at that point, people are moving from this, I'm going to download Netflix and I can cache it kind of a thing, and how the internet has progressed over time, to pushing data upwards, which the internet has not been built for. And we're seeing the same problem in energy, right? Like energy grids. It's a very, very, close analogy, where before everyone was consumers of energy, and now people are producing energy and, pulling more energy than they typically would, like with a car. And that's changing the dynamics drastically and stressing these networks that typically seem pretty straightforward. Plant, extra plant, wires to buildings and homes, right? Now it's like, here's a solar, here's a wind, here's a battery, here's whatever, right? And these things are not built for it, and the internet isn't either. And so that's where we're not trying to put a Band-Aid on it, but we are trying to restructure it by making an OS out of the whole thing, where the compute and the network are one and the same, versus everyone trying to separate it as just a transport network, which you really shouldn't.
I appreciate your framing around who your customer is. It sounds like Mutable's maintained an openness about who that is. I think you talk about, pushing it on the operators. It very much seems you're working in harmony with where the natural progression of the tech is for distributing data, rather than trying to just reinvent that wheel.
Yeah, no, when you're small, CapEx is a problem, right? So I can go ahead and raise a crap load of money like StackPath or many of these other guys and try and put compute everywhere. But what's the real success of that when in 4 years I got to replace that hardware? And if I haven't captured enough money on that first side, basically that venture is going to die, right? But if you're using compute that's already out there or already has value in another way, then that ROI changes drastically, right? And so even cloud providers go out and they put a bunch of compute. They might put it in Anchorage, right? Or they might put it in a lot of major cities. But are they really going to venture too far out? The ROI doesn't make any sense. It's like the hotel business, right? Like, you're going to be in major cities because you can fill that up because it's solely dedicated for that purpose. But that's where Airbnb came in, and that's why we mentioned this in the beginning, is that Airbnb, you can, have a log cabin that now you can use that's next to a ski resort or where your family is or whatever it is. And that extends the reach to have ubiquitousness. And that's what we're doing by tying all these resources together, because the operators have the CapEx. Don't get me wrong. Even businesses like retail stores have some of these things in it, like a Target might have for self-checkout, right? And tying all this together, more enterprise grade hardware, not, your computer or something like that, but like real enterprise and tying it all together, then yeah, this is totally doable in a short amount of time versus, trying to get one company to push money everywhere and hopefully it all works.
Fantastic. I want to keep the Q&A going here, but we're beginning to come up on 8 o'clock Alaska time. And generally we like to close out and have a little bit of time for our speaker to stick around and answer more questions. I want to be respectful of your time, Pelle, and see if you'd be willing to stick around for a few minutes more.
Sure.
Fantastic. Well, I also want to make sure that I pass over to Nigel Sharp. This event wouldn't have been possible without him or Center Ice making the introductions here. So please, Nigel, tell us a little bit more about that.
Yeah, thanks, Bradley. Well, it's great to be sort of hanging out with this audience. I know this is not my first time at a Dev Alliance meeting, and it sure won't be my last. I think this is a great crowd. And I'm really glad that we kind of partnered on this particular event. So, Pelle, when we start talking about sort of networks and the ubiquity of that, I sort of go back into my day hat, which is entrepreneur ecosystem building and just ecosystem building in general. And realizing that, connections and interconnections are all just a web that gets weaved through your life and you're never quite sure where they lead. And I look back, I got reached out to by a couple of folks who I think work in your team, who I engaged with in Armenia, years ago in a sort of previous life where I was doing IT work. And, it was really random because I think, the context of how I knew those guys and then Mutable did not overlap in my mind at all. And they started throwing out names of people that I worked with in Colorado, when I was wearing sort of more of a related kind of hat in, the network function virtualization and the software-defined networking space. And it's really fascinating to sort of just see these interconnections. And to me, it's really cool. And I said this to Bradley, I just thought it was really cool that, this particular event kind of links together some of my connections from Armenia to some of my connections in Colorado and to Alaska. And that's just, my life network that's kind of like working itself through. And then we're able to sort of like, literally move the content from one place, right, and serve it up in another. So I think actually you guys will appreciate the analogy there, at least in the way this has worked out. So Center Ice, in brief, for those of you who aren't aware, is a program that runs under the University of Alaska. We're a statewide program that engages in trying to spread the spirit of entrepreneurship by giving funding, experiences, and support to those who are interested in sort of startups and entrepreneurs. And when I heard about Mutable, they reached out and said, like, look, are you aware of any startups in Alaska who may be wanting to build new services, that could benefit from edge computing? And I said, like, off the top of my head, there's a couple of ideas, maybe the drone companies, maybe people doing some big data analysis, so on and so forth. But I said the best thing to do is just come in and hang out with the folks in Alaska a little bit and get on calls like this with the Dev Alliance, because this is where all the cool tech people hang out, and just spread the awareness of, like, these services could soon be available in the state. And yeah, it's a great honor to have you engaging us, Pelle. And like, it's nice because I think Alaska is it's an afterthought for a lot of people, and to see you guys embracing it as one of your early proving grounds is what I'm going to frame it as. I think is really exciting because Alaska, I think, it's a really fascinating case study. We have that urban component, we have that rural component, we've got communication challenges across the realm. And, I always love the story from Duncan, who was the CEO of GCI at the time. And, when he spoke about GCI just not being, a realistic or feasible business model to any other telecom network in the country, no one was ready to make that investment, and how they went out there and just did it. And they proved everybody wrong, and they just kind of did that. And I think, we're at the same stage now where you're talking about putting in new platform capability for folks that, other people will be like, oh, there's no need for it. Like, it's just such a micro use cases in Alaska. And then it's going to be folks like Bradley and Peter and whoever else on the call who suddenly have real use cases, real products, real services they can provide and use this. And that's where exciting stuff happens. And that's my job, right? Day to day is to be here to sort of be an interconnector and bring these ecosystems together. So yeah, it's been a great honor to pull this event together. I hope the Mutable has a chance to keep engaging with the Alaska ecosystem. You guys are very welcome. And I do appreciate just sort of the geekiness of this group, and yet the power of sort of platform change and mindset. So yeah, really do appreciate that. And I think I'll pass it back to you, Bradley. I don't think I have much else to say.
Thanks, Nigel. Same. I hope you guys join the Slack. It's a great way to keep in touch with this community and continue the Q&A long after this is over. A couple more questions on that note into the chat. Demetrios would like to know, along the lines of pushing energy upwards, we were talking about earlier, do you see use cases involving blockchain and edge computing?
Yeah, and before I address that, before anyone jumps off or anything, I want you to keep in mind that I'm not proposing this as a hypothetical. I am saying that we are getting compute with GCI up there in Alaska in a couple months, and this is real. So all of you who actually want to participate and be involved and try and run things that make sense for trying against it, please reach out, right? This is not a hypothetical. This isn't a science experiment or a thought process experiment. This is, a real thing. So please, and the more use cases that come alive and the more places where it's demanding, and I know GCI, as you guys do, as being people who are really willing to put their neck out there and to try and test things out and beat the odds, they're willing to put more compute out if we have more real use cases and real locations to expand outside of Anchorage. So keep that all in mind. So with that, the question is more about kind of like the involvement of blockchain and edge computing and how that ties together. Sorry, my camera. So blockchain is an interesting thing. It's not necessarily needed in controlled environments if you're talking about the properties of being a hyperledger. So hyperledger is literally just a record of things. When you're trying to add trust in a decentralized way, that's when a hyperledger comes in, because you're basically verifying it with someone else. And that creates some sort of consensus that someone didn't manufacture a record that people aren't aware of. And so we're seeing that in supply chain. We're seeing that in, when you're creating agriculture and you want to track things all the way up from its origin. When you're introducing a bunch of parties, that makes a lot of sense. Is that needed in an environment where things are controlled? I think it's actually wastes more energy and isn't really the primary use of it. The other is definitely. How that ties with edge computing. So if there's more compute being done on devices, or if we're having multiple devices that are owned by different people, for example, let's say some reason someone wanted to do a drone delivery service and they wanted to use someone else's drones while they're not using it and put it part of this cluster, right? In that case, you might want to track things. You might want to say, hey, look, I want to make sure that, there's no screwing around on what happened with the data. Then yeah, that would make sense. And energy overall, it's quite interesting because of all the different sources, like what you just said with the access networks, like satellites and stuff like that. We're not having a homogeneous network anymore on the energy side, right? So will things evolve that might say, hey, look, there is a meter for this particular wind turbine that someone owns privately for their farm, that they're going to open up that energy for other people to use and be able to get that money back for whoever uses it, and want to track it that way, then sure, that might be an example of it.
I think, just to kind of pivot off of that, I think about, certainly the next generation or level 5 self-driving cars, which we're not seeing on the market yet, but certainly, cars that are approaching class 5 autonomy are going to have pretty beefy GPUs, even by the standards of 2025, 2030. How can those GPUs be utilized while those cars are sitting in the garage? And how do you essentially have, as you say, systems of trust that are coherent for that quantity of enterprise class compute?
Yeah, I try and see it a different way, if possible. I know everyone's thought pattern has been, from an engineering perspective, especially if you're embedded systems developer, like a designer or developer or engineer, is I don't trust the network. You're like, I need everything to run on this standalone as if the network doesn't exist, because in their mind, that was reality. With this new infusion of different types of access networks, I'm really hoping that that mentality changes, because that's really what these access networks are really trying to do. And with that, it goes to what you're saying, Bradley, where you want to have the compute off of the device, because then the device is cheaper. And then the device can also last longer with battery. And the device can also get updates and tell it what to do, because you're not having to go in and replace a GPU chip and make sure the interface is the same than it was 10 years ago when you bought the car, right? So the ideal situation is, let's have devices like cars actually have a lower amount of compute on it. Not saying that they can't do things on its own. I think that needs to happen for sure. But there are some tampering down. And the more, it's not about telling the car what to do, but giving the car more information, right? Right now, cars, if you're trying to get to that level of autonomy, has to essentially predict a million different possibilities every second. Because in its mind, there's very limited information, and therefore it has to try and figure out every single scenario, focus on the problem ones, and then make sure they navigate against it, right? But the more information that it's able to get, it can maybe go, instead of a million different predictions per second, to 10,000, right? And that number drastically can reduce the amount of energy spent, the type of compute that's in it, as well as be able to basically prolong the life of the car to some degree, right? And so that's really what we want to get to. Don't get me wrong, it's not how people are building things today. It is not how the thing works. But I am skeptical of the idea of taking compute from home or taking compute from devices that are out in the field, because there's a crazy, and using them for workloads, because there's a crazy amount of unpredictability in what the capabilities as well as the life cycle of that device currently is, right? It's a lot easier to do it where it's a traditional data center type of system, has all the IPMI, like all the statistics you can get off the devices that are there, and it's in a more controlled environment. So there might be totally exploration to do what you're talking about, but I'd rather have that car that is smart not sit in the garage, but go out and serve more people in the area, right? That's how I would see it.
Awesome. Any other questions, either to chime in or in the chat here?
So yeah, there seems to be one about security, right?
Yes.
And this is interesting, because when everyone thinks about edge computing, they harp on latency, right? Because everyone's taught edge computing means closeness, which means speed of light, which means latency. And that's not all the use cases. I actually would believe it's actually not majority of the use cases. Bandwidth is definitely a big one, right? As we talked about, not just download, but the idea of, I think one of the biggest components of use of edge computing is going to be video analytics in real time, right? So taking the feed from your drones that you're maybe doing, oil rig inspections or pipeline inspections or forest fire, prevention, all those type of things, right? Taking all those real-time videos, especially since so much infrastructure has video, and running that, closer on the edge for network constraints and many other concerns, but also for security, right? Because I think one of the biggest things that most people don't realize is that a lot of the times the cable and telco providers are also the enterprise network for these companies and entities, right? They provide what's called an SD-WAN, or software-defined wide area network, right? Where essentially the firewall is on the operator's infrastructure, not necessarily on every single physical location and independent of one another, right? So they create these global firewall rules. It's on the top level over there. And then all the retail stores or all the factories or all the rigs, everything gets connected together over that, overlay network. That's the operator that divides it from the internet. So if you have that layer of security, right? Essentially what we're doing is, if we put the compute on that network, then technically we're on premise without being on premise, right? And that actually opens the doors for a lot more things. Not every use case needs to have the latency or bandwidth value, but the security is on everyone's mind. And being inside those firewalls, inside the operator's network or at the edge of the network, next to a rig, whatever it is, I think is one of the bigger values here that, you know, not just a consumer would have, but a lot of the enterprises and businesses in the area. So instead of having IT staff go out to these field locations or go to a target, right, to fix these self-checkout machines where they have the compute, you know, in the building, and you have to have an IBM or SAP or one of these big companies come and service it, you actually are having these in elastic style compute right nearby at the provider level. And that gives you the best of both worlds. You have a whole bunch of smaller companies participate because they have access to this, you know, more dynamic style compute while still going in the security profile that a lot of these companies are looking for.
Awesome. This always happens at the end. We're stacked with questions now in the chat. So Nigel was wondering if you could touch on, you know, the possibilities of redemocratizing the network or perhaps demonopolizing servers.
Let's skip my question. I think I've had a chance to already talk.
Okay. All right.
Because that's more of a philosophical if we had nothing else to talk about. Chew on that for a while.
Appreciate the energy, keeping it going. Jeff, did you have a question you wanted to chime in with?
Yeah. So how do you see transport protocols changing as a result of this? So like right now, in terms of being a web developer, right? Like everybody's transferring things via REST and JSON and stuff. But as we're going more to edge compute and you can distribute the processing, do you see a lot more like binary protocols becoming more common, like gRPC, where, you know, you can do that edge processing and then it reduces the cost of data transfer as well?
Well, you're already reducing the cost of data transfer by moving it closer and doing that. But at the same time, I definitely promote the use of gRPC. The fact is that we should be using more binary-based protocols that have more defined structure that can be shared than just using document-based, you know, sharing of data, because machines aren't built off of documents. That's for humans, right? We should be sending things with binary. It makes a lot of sense. And also, I do think that when you have servers so close to each other, I think we can have things more with, you know, the WebSocket slash, you know, all of those socket type of protocols where literally everything's always connected. Because you have the distributedness, it costs less to do than doing it at scale where all these connections are having, you know, a kept alive socket that's going across the, you know, the internet. So that means that we can build more applications where we can expect the response rate and, you know, all that kind of stuff and data to be a lot faster and a lot smaller and do that more at scale. Like, for example, how are you going to communicate with that drone to give it commands? Probably some sort of, you know, gRPC based socket kind of communication. You can do UDP, don't get me wrong, but a lot of these things, right, make a lot of sense to do nowadays versus before when you were, you know, forced to try and trickle as much as you can just because the network wasn't there. The access networks are getting larger, so you can send more, but obviously we should optimize all the time where it makes sense.
It's amazing how little bandwidth you need for telemetry, though, I'll tell you that.
I hear you.
Question from Aaron Johnson here. I'm going to try and paraphrase here. Essentially, you know, how does this work with web circa 1997 technologies that were all very much mired in TLS, geolocation, IP addresses? How do you handle that layer?
Yeah. So I'm not sure if I really want to go too much into SPFs as much, but essentially what we're doing is we're running Anycast, right? Just like Google does it with their DNS, you know, 8.8.8.8 or you know, what is it, 1.1.1.1 with Cloudflare. So you essentially are putting out one major IP, and then all the servers basically accept that one IP, goes to the nearest server as a load balancer, and then from there, based on the domain and how it's parsed out, that's essentially how we use to identify each thing. And then obviously route the traffic based on that internally over IP6. There are circumstances where we will expose obviously more IPs, as well as, having direct to container or direct to VM via an, IP6 that we pass along, or do some NAT, right, with IP4. So a lot of that is a translation layer that we run on every single machine that does everything from the BGP sessions to the load balancing to running workloads. So that's kind of how we handle it, is we do a lot of that TLS termination, all that kind of stuff at the edge of the network, right when the request comes in, and the rest of it, we try and keep it clear of all that crazy old nonsense.
Awesome. Well, going once for questions. Anybody else been holding back?
Question about video conferencing and I guess the possibility for e-learning. As we've seen over this past year, everyone has shifted to this e-learning model like very rapidly, and I'm curious how video conferencing in maybe rural parts of Alaska could either be better served with video conferencing, and how Mutable is approaching video in addition to the other technologies that you talked about.
Yeah, it's quite interesting, right? If we just talk about video conferencing in general, it's very different from video conferencing in those circumstances that you just talked about. And the reason why is the way it's structured today is everyone's forced to be home and the same teacher is still giving that class. That can be hyper local, right? You can literally have those, that data and those people work together and have a server hyper local to serve that community. Versus, I'm over here in Bloomfield, right, in Colorado. You guys are over there. Somebody might be coming in. So don't get me wrong. I should get the worst end of the stick, and then everyone else by you, because you're the main, populace, should be getting the best experience, right? And that's not how it works today. Essentially, how it works is kind of like how the old cellular networks used to work, where essentially, or still do, they take everyone, they go to a pretty centralized location, and they spit it back out, right? Google Meet, for example, how it works is the first person that joins, it creates a container by them, all right? And then essentially everyone just joins in that container, and wherever that container is essentially where, that video distribution is happening. So with our style of compute, you can be a lot more aware of where the user's coming from, and potentially reform these servers periodically to adjust to be hyper local, because you aren't limited to just Google's infrastructure because you're a Google platform, or in this case, Zoom's platform, because Zoom has a bunch of servers they put in major cities. The major cities doesn't mean it covers a lot of the smaller areas for sure.
On that note of compute, Andre asks what the smallest unit of compute is that becomes part of your system before there's diminishing returns.
So we're going to be probably doing it in blocks of around 64 megs of memory, and trying to actually go quite small. GPUs is a different story. They can only be sliced so many times in so many different ways. The newest way of doing it, you could do it around like, you can break something down if we're talking about just compute side of it, not like the visual graphics, VDI or cloud gaming. You can break it down into 7 different segments that are heterogeneous, actually, meaning you could have different size segments for the compute side that things can be broken down, which is fantastic. So video processing that you're talking about, Bradley, and stuff like that, and video analytics, that can be done in a compute manner, and broken down in different ways. If we're doing VDI, meaning remote desktop or cloud gaming, those are very stringent on once you set a profile, let's say, 8 gigs of memory per GPU, or frame buffer, that's all you get, right? And you have to break everything across that way. So yeah, we are going quite low, because our ideal situation is not one person owns one box in terms of utilization. The idea is that one box can service 1,000 customers, because you can split things up and you only run it when you need it. And the smaller the unit is of some of these containers, the easier it is to copy to memory the whole entire state of what that machine is, copy it from memory to disk, and then we can hot load that in other places. And if we can do that in near real time, it's as if you're having a continuous session jump from location to location. So that's what we're trying to aim for in the future.
Wonderful. Well, on that, we're at 8:15 local here, so I want to give folks a chance to break away and do other things this evening. Pelle, I know you're coming to us 2 time zones ahead, so I appreciate you staying late and talking about all this. Truly fascinating and remarkable to see how this unfolds for Alaska. Your company's clearly on to a need here, and it'll be exciting to see how that shapes up.
For sure. And obviously, Nigel, I think there's a little bit more to what you had as a question than what I answered before. So if you still want to go into that, we totally could.
I would almost never say no, but it's I recognize that Bradley also wants to wrap this session up. I think that it's I always hope with these things that we sort of like start inspiring in the future and like looking at like opportunities. And I know that this crowd will reverberate out into the ecosystem, and it's always interesting what these ripples can do. So I don't know, I would love to hear the great success stories that come out of this, and then it's folks like yourself, Pelle, and other folks on this call that starts thinking about what the future of the world, connected world, looks like, and that's where to me more the geekiness and of the future philosophy kicks in. And there's a lot packed into that question. I was actually having some fun side private chats here with a couple of folks who just wanted to geek out with me a little bit and enjoy the idea of futuristic democratization of mini data centers in people's Teslas, and how does everyone start monetizing those through blockchain, blah blah blah. So we've had some fun. I've had satisfying side chats as well as listening to you. So
well, Nigel, maybe what we can do is we can cut the stream here and we can move on to happy hour, and people can chat as long as we want. How's that sound?
I can end the stream.
That's good. Jeff, you're still executive director for at least one more of these things, so I think you get to decide.
Oh, I see. Pushing the power on.